Good morning. I have here an additional example for measures of central tendency and dispersion. So for our problem, nurses on the 8th floor of community hospital believe they need extra staffing at night. To estimate the night workload, a random sample of 48 nights was used. For each night, the total number of room calls to the nurses station on the 8th floor was recorded as follows. So, for our raw data, we need to arrange this in order by using the stem and leaf display. Okay, so we have our smallest value is I think 37, and then our highest value is 102. Okay, so we have here 3, 4, 5, 6, 7, 8, 9, and 10. This will be our stem. Okay, so for 68, we have there 68, then 46, 62, 93, then 60, 48, 100, 92, 69, 84, 90, 77, 70, 82, 37, 100, 83, 75, 88, 65, 58, 63, 70, 82, 90, 101, 87, 74, 86, 77, 65, 86, 71, 102, 75, 85, 71, 80, 70, 92, 86, 70, 95, 85, 80, 70, 73, 82. Okay, so we have there our stem and leaf display. It is much easier to arrange our data in order. Okay, next, let me change the color of my pen. Okay, so we have here 37. Okay, then we have 46, then 48, then 58, then we have 60, then we have 62, and then we have 63, then 65, okay, and then 68, then 69. Okay, next we have 70. 1, 2, 3, 4, 5. Okay, next is 71. Okay, 71, and the next is 73. Okay, then 74, then 75. 1, 2. Okay, then 77. 1, 2. Okay, the next 80. Okay, 1, 2, and then we have 82. We have 1, 2, 3. And the next we have 84. Then 85. 2. Then next is 86. We have 1, 2, 3. The next is 87. Then, oh wait, I forgot 83. We have here 83. Okay. Oh, wait. This is 83. Then this will be 84. I'll adjust 84. Then this will be 85. And then we have here 86. Okay? Then that's it. 86. Then we have 87. Okay, wait. 87. Then we have 88. And then we have 90. Okay? Then 92. Then 93. 95. Okay? 100. Then 101. Then 102. So we have there 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have there N is 48. Okay. Next is we have here our ungrouped data. Okay. So for this ungrouped data, we compute for the mean, median, and mode. We have here the mean, that is the summation of x over n, or okay, that is you need to add everything then divided by 48, or you may use your calculator again. Okay, you need to set it at mode stat. So what are you going to do? That is mode 3.1. Then you input all the values. Okay, then after that you press on, then shift 1, then choose 4. Okay, so you have there number 2 is the mean and number 4 is the standard deviation. Okay, so let me use this calculate technique. For our mean, we have there 77.4. Okay, next is for the median. Okay, median. We have there n over 2. That is 48 over 2 is 24. That is the place, 24th place. What is our 24th value? We have there 77. Okay, next is the mode. Okay, for the mode, that is the most frequent value that appeared. We have there 70. Okay, next is the standard deviation. Okay, so for the standard deviation again, we use our calculate technique. That is mode 3.1, and then input all the values, then shift 1, 4, 4. Okay, for the standard deviation, again, the formula for standard deviation is the square root of the summation of x minus x bar squared over n minus 1. Okay, so of course I use the calculator technique. Our S is, or our standard deviation is 14.33. Okay, then let us square this for the variance. Our variance is 14.33 squared is 205.22. Okay, then we can now compute for the coefficient of variation, that is CV, that is S over X bar times 100, and that is equal to, what is our S? We have 14.33 divided by our mean of 77.4 times 100, and that is equal to 18.51%. Okay, then next is, okay, I almost forgot the range. Okay, so the range is of course the highest value minus the lowest value, and that is 102 minus 37. We have a range of 65. Okay, then next is of course the mean deviation. Okay, so for the mean deviation, okay, so for the mean deviation, that is the summation of the absolute value of x minus x bar over n. So, I did this manually, okay? So, for the mean deviation, for the summation of x minus x bar, the absolute value is 547, okay? Divided by our n is 48. That is equal to 11.4, okay? So, for this one, for the mean deviation, okay, this x minus x bar, I'll just explain it, okay? So, for this one, okay, so we all know that our x bar or the mean is 77.4. I need to get the difference, okay, between these x values, okay, okay, and the mean of 77.4. So that would be 37 minus 77.4, then plus 46 minus 77.4, plus 48 minus 77.4, and so on until 102. Okay, so then divided by 48, it gives me an answer of 11.4. Okay, next is we can compute now for our skewness. Okay, so our skewness is equal to 3 times the mean minus our median, okay, divided by our standard deviation. And this is equal to 3 times our mean of 77.4 minus our median of 77 divided by our standard deviation of 14.33. So our skewness is equal to 0.0837 or 0.08. Okay, then next is let us compute for the quantiles. Okay, for the quantiles, we have Q1. Q1 is n over 4, and that is 48 divided by 4, that is equal to 12. What is our 12th place? We have there, okay, 1, 2, 3, 4, 5, 6. So that is, this is our Q1, 70. Okay, we have there 70. Q2 is the same as the median. That is 2n over 4, that is 2 times 48. Divided by 4, we have there 24. So what is the 24th place? We have 77. Okay, so we have here 77. The next is we have Q3. Q3 is 3n over 4, and that is 3 times 48 divided by 4, that is equal to 36. Okay, what is the 36th place? We have there 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. That is our Q3. 86. Okay, next is D3. So we have there 3 times 48 divided by 10. That is, we have 14.4, or we can round it up to 15th place, and it's equal to 70. Okay, 15. This one. Okay, next is D5. D5 is also equal to Q2, that is 5 times 48 divided by 10. It gives us 24th place, that is 77. Okay, next is D8, that is 8 times 48 divided by 10, and it's equal to, we have 38.4, and that, of course, we round it up, it gives us 39th place. Okay, so what is the 39th place? If this is 36, 37, 38, 39, we have there 90. Okay, so we have here 90. Next, we have P10. That is 10 times 48 divided by 100. Okay, so we have there, for 10 times 48 divided by 100 is 4.8. So round it up again. This is fifth value. We have there, our fifth value is 60. Okay, we have here 60. Next, P50. Okay, again, P50 median, D5 Q2 is the same, equal. We have here 50 times 48 divided by 100. We have there 24th place, and that is 77. Okay, what about P90? Okay, that is 90 times 48 divided by 100. That is, we have 43.2, or we round it up, it will be 44th place. Okay, what is our 44th place? We have there 95. Okay, so that is 95. Then we now have our quantiles. We can now compute for the kurtosis. Okay, our kurtosis is equal to Q3 minus Q1 divided by 2 divided by P90 minus P10. Okay, so we have there, our Q3 is 86 minus our Q1 is 70 divided by 2 divided by P90 minus P10. Okay, so our kurtosis is equal to 0. Let me erase this. Okay, 0.229. Okay. Okay, so remember, this is for our Q3, for our QD, that is Q3 minus Q1 divided by 2, and this is equal to 86 minus 70 divided by 2. We have there 8. Okay, so then another one is IQ, or the interquartile range, that is Q3 minus Q1, and that is equal to 86 minus 70, and that gives us 16. Okay, next is, okay, let us say I want to compute for the 75% of my data. Where does it fall? Okay, so using the Chevyshev's theorem, we have there, for at 75%, we have mu plus minus 2 standard deviations. And of course, our mean is 77.4. That would be plus minus 2 times our standard deviation of 14.33. And it gives me, okay, we have 48.74 to 106.06. So my data falls in this interval. 75% of my data falls in this interval. Okay? So, another one, we have the range. Okay? CD range, or coefficient of dispersion. We have CD range, that is equal to, we have the highest value minus the lowest value over highest value plus the lowest value, and that is 102 minus 37 divided by 102 plus 37, and this is 0.468. Okay, then what about the CDQD, quartile deviation? We have your CD of the quartile deviation, that is Q3 minus Q1 divided by Q3 plus Q1, that is 86 minus 70 over 86 plus 70. And this is equal to 0.1026. Okay? For the CD of the standard deviation, okay, anyways, that is the coefficient of variation. We have there 14, oh wait, that is S over X bar. That is 14.33 divided by 77.4, and that is equal to 0.1851. Okay, next is we have the CD of mean deviation. For the mean deviation, we have 11.4 divided by the mean. Okay, wait, I'll write the formula. We have here the mean deviation divided by X bar, and this is equal to 11.4 divided by 77.4, and it gives us 0.147. Okay, then we can now draw our box and whisker plot. Okay, so for the box and whisker plot, we have our lowest value is 37 and our highest value is 102. Okay, so let's say I have here, this is our, say this is 30, then 40, 50, 60, 70, 80, 90, 100, 110. Okay, this is our scale. Then locate our lowest value of 37. So 37 is here. Okay, then for our first quartile, we have a 70. Okay, our Q1 is 70. Then for our median, what is our median? We have, for the median, we have there 77. Okay, so we have here 77. Okay, then for our third quartile, we have 86. This is our box, and then this is our whisker. And of course, the highest value is 102. This is our highest value, that is 102. Okay, so this is our box and whisker plot. Okay, so this is for ungroup data. Okay, what about the group data? Okay, so let us have our group data here. Okay, so in our group data, we need to develop our frequency table. Okay, let us say I want 5 classes. Okay, 5 classes. So let's say we have here class width is equal to the highest value of 102 minus 37 divided by 5. Okay, so that would be equal to 13. So this will be rounded up to 14. Okay, next we have here the class limits, then class boundaries, then midpoint, and then a frequency, then less than cumulative frequency, greater than cumulative frequency. Okay, oh, I think we don't need the greater than cumulative frequency and the relative frequency. Okay, so since we are not going to draw our polygons, and histogram. Okay, so for the class limit, we have there class limits. We have 14 is our class width. Our lowest value is 37. So let's start with 37. So since our class width is 14, we can just add 14 to 37 for the next lower limit. So 37 plus 14, we have there 51 plus 14, that is 65, plus 14, 79, plus 14, 93. Okay, so for the upper limit, since this is 50, this will be 50. 51, this is 50. Okay, then 50 plus 14, that is 64, then 78, then 92, plus 14, we have 106. Okay, then for the continuity correction, we need to subtract 0.5 to the lower limit and add 0.5 to the upper limit. So this will be 36.5 to 50.5, then 50.5 to 64.5. Okay, as you can see, we have there now our continuity. 50.5, okay, then 64.5 to 78.5, 78.5 to 92.5, 92.5 to 106.5. And then again, for the midpoints, we just need to add the lower class limit and the upper class limit, then divide it by 2. So we have there 37 plus 50 divided by 2 is 43.5. Okay, then the next, of course, this is by 14, so we can just add 14 here. So we have there 57.5 plus 14, 71.5, then 85.5 plus 14, we have 99.5. You can check. 93 plus 106 divided by 2 is 99.5. Okay, the next is for the frequency. Okay, so I already tallied all our data values from this ungrouped data. Okay, so let me just list down all the frequencies here. So for 37 to 50, I counted 3 values that falls in that class. Then 51 to 64, we have 7. Then 24, then 42, then 48. Again, you can just count or tally the values that falls in these classes. Okay? Then, oh, sorry. This is 3, then 4, then 17, then 18, then 6. Okay, what I've listed down is the less than cumulative frequency. So that is 3 plus 4 is 7, plus 17 is 24, plus 18 is 42, plus 6 is 48. Okay, then next is we can now compute for our mean. Okay, so for our mean, we have there the summation of xf over n. Okay, our x is the midpoint and our f is the frequency. Okay, let me change the color of my pen. Okay, this is our x values and this is our f values. Okay, so for this one, okay, let me change it again. For this one, we have okay, or we can use the calculator technique. But before that, it is simply you multiply your midpoint by its frequency, then you get the sum, and then divide it by 48, that is n. Or you can use the calculator technique. You just need to turn on the frequency, that is by pressing shift, then mode, then arrow down, then choose stat, then frequency on, that will be 1, and then again mode 3-1, and then you just need to input the values of x and f. Okay, after that you press on, then shift 1, then again 4-2, that would be for the mean. If you need the standard deviation, that would be 4-4. Okay, so for this one, I've used the calculator technique. So for the mean, okay, that is, we have 77.33. Okay, then for the standard deviation, we have there 14.39. Okay, of course, square this, that gives us the variance of 207.12. Okay, so for the range, in computing for the range, that is the highest class boundary minus the lowest class boundary, that is 106.5 minus 36.5, that gives us 70. Okay, the next is let us compute for the mode. Okay, in computing for the mode, you just need to look at, okay, let me change again the color of my pen to let us say blue. Okay, so for the mode, we just need to look into the highest frequency, and it gives us 18. Okay, so for that, we have here 18 minus the upper value, okay, that is 17, divided by 2 times 18, okay, that's the frequency, the highest frequency, minus the value on the upper part, that is 17, minus the lower value below, okay, minus 6. Okay, multiplied by the class width, that is 14, plus, of course, you are going to add this to the lower class boundary at the, okay, located at the column where, or the row where the, where the highest frequency is. Okay, so we have it here. Okay, yan. We have there 78.5. Okay, so for our mode, we have there 79.58. Okay, then in computing for the, let me change again the color of my pen. Okay, in computing for the median, okay, the median, it's just the same as computing for the rest of the quantiles. Okay, so let us compute for the median, then later on we can just choose from the quantiles. Okay, so for the median, again, okay, so for the median, that is of course n over 2. So since our n is 48 divided by 2, it gives us 24. Okay, 24, let me change again the color of my pen to blue. For 24, you need to locate this in the less than cumulative frequency. Okay, so 24 is here. Okay, so for 24 minus, okay, the upper value, we have there 7 divided by the frequency at the row below, 7, this is 17. Okay, then multiplied by the class width of 14, okay, plus of course the lower class boundary again, we have here 64.5. Okay, so our median is 78.5. Okay, so let's try the first quartile. Okay, so for the first quartile, we have there n over 4. So our n over 4, 48 divided by 4 is 12. Okay, so where is 12? 12 is in between 7 and 24. So 12 minus the value, this value, okay, divided by the frequency, okay, this one, 17, okay, times 14, the class width, plus the lower class boundary in the row, okay, of the frequency. We have here 64.5. So Q1 is 68.62. Okay, so let's say I want to compute for Q3. Q3 is 3n over 4. So that's 3 times 48 divided by 4 is 36. So where is 36? It is located in between 24 and 42. So we have there 36 minus the value above, that is 24, divided by the frequency below. We have there 18. Okay? Times the class width of 14. Then what is the lower class boundary in the row of the frequency? We have 78.5. Okay? So our Q3 is equal to 87.83. Okay? Next is, let's say I want to compute for D3. Okay, D3 is equal to, again, so we have 3 times 48 divided by 10. We have 14.4. Okay, you don't need to round up the value. So that is 14.4 minus, where is 14.4? In between 7 and 24. So this will be minus 7 divided by what is the frequency below, that is 17. Okay, times 14, the class width, plus what is the lower class boundary at the frequency row? We have there 64.5. So this is equal to what? 70.59. Okay, so in computing for the quantiles, you use this process. Okay, so anyways, that's all. Thank you very much for listening.